Hello guys, section 10-2 angles of rotation. Last time you started studying trigonometry. Section 10-1 you studied some fundamental concepts in trigonometry. You studied the 60 trigonometric functions, sine, cosine, tan and their reciprocals. Today we're going to continue in the same way studying the basic concepts of trigonometry. Today you're going to learn how to draw an angle in the standard position, and you're going to learn how to find the trigonometric functions or trigonometric ratios of an angle in the standard position. Guys, let's talk about angle in the standard position. Guys, you know the coordinate plane is made up of x-axis, the horizontal axis, and a perpendicular vertical axis, the y-axis. And the two axes divide the coordinate plane into four quadrants. This is the first quadrant, this is the second one, and this is the third one, and this is quadrant 4. Guys, to draw an angle in the standard position, you need to place the vertex of this angle exactly at the origin point O. O is an ordered pair 0, 0. So we call this side the initial side, and every time you draw angle in the standard position, you place the initial side on the positive direction of x-axis, and we call it initial side. The other side, guys, is called the terminal side, and this side is the rotating one. The terminal side is the other side of this angle, and we obtain the terminal side by rotating the initial side clockwise direction or counterclockwise direction. If the rotation is clockwise direction, the angle gonna be a negative angle, like this angle, negative 45. We start from 0 and we rotate 45 degrees clockwise direction. This negative sign refers to the direction, not the measure of the angle. The amount of rotation is 45 degrees and the negative sign is clockwise direction. If the rotation is counterclockwise, it's going to be a positive angle. So we start from the vertex. The vertex is exactly at the origin. We draw the initial side on the positive direction of x-axis, and we rotate this side 135 degrees, and this is going to be the terminal side of the angle. So this angle is a positive one. Example 1, draw an angle with the given measure in a standard position. So our job is to draw an angle in the standard position. The first one is 320 degrees. Again, guys, we start from the origin point. This is the vertex of the angle, and we draw the initial side exactly on the positive direction of x-axis. So this is our initial side of that angle. And we need to identify the direction of rotation. Because the measure is positive, that the direction of the rotation is going to be counterclockwise direction. So we're going to rotate counterclockwise direction. Guys, 320. Guys, if you start from here, this is 0. Quarter of the way is 90 degrees. Half the way is 180 degrees signal. Yes. 3/4 of a complete round is 270 degrees. So every time you add 90, 90 plus 90 is 180. 180 plus 90 is 270. If you add another 90 when you complete a complete round, when you make a complete round, it's going to be 360. So guys, at 0 it's a 360 at the same time. Now our angle is 320 degrees, so it's greater than 270 and less than 360. It's beyond 270 by 50 degrees, so it's gonna be somewhere like here. We're not drawing exact graph using or exact angle using a protractor. We only creating a rough graph of the angle. The very important thing is to show a couple of things. The vertex of the angle is at the origin, the initial side and the terminal side, and you need to show the direction of rotation. This is the direction, is this way, so you add head arrow in order to show the direction, and you put the measure of the angle. So theta equals, we use the letter theta, 320 degrees. Another angle, guys, negative 110. So this is the vertex, and this is the initial side, exactly on the positive direction of x-axis. Guys, the rotation this time is clockwise direction. How do you know? From this negative sign, and the measure is 110. Guys, if you start from 0 and you make quarter of the way, you rotate quarter of the way, this is gonna be 90, and half of a complete round is 180. If you add more 90, it's gonna be 270, and if you make a complete round, it's gonna be 360. So we change the direction of rotation this time because the angle is a -1, so rotation is clockwise direction. Guys, it's 110. 110 is beyond the 90 with 20 degrees. So this is my terminal side, and this is the direction of rotation. In this situation, theta equals -110. Remember, guys, negative because of the direction, not because of the amount of rotation. Another angle, and this one is kind of tricky one because the measure of the angle is quite large. 990 is, how do I obtain this angle? And one complete round is 360 degrees. Guys, first of all, place the vertex of the angle at the origin and draw the initial side. This is the initial side. The direction is counterclockwise because it's a positive angle. So guys, if we start from here and we made a complete round, this is 360. So I didn't reach 990. We are very far from 990. So we can make another complete round, continue making another complete round. Guys, 2 rounds, 2 360 are 720. We didn't reach 990, so we need to continue rotating. So guys, what is the difference between 990 and 720? The difference is 270 degrees, so we need to continue rotating another 270 degrees. From this point, guys, we rotate. This is 90, this is 180, this is 270, so we need to stop at this point. And guys, now we can draw the terminal side of this angle. This is going to be the terminal side of this angle. So this angle is 2 complete rounds plus 3/4 of a third round. This is our angle. Theta equals 990 degrees. Another concept, guys, coterminal angles. What are coterminal angles? They are angles in the standard position. So all of them or both of them are in the standard position with the same coterminal side. With the same terminal side. So coterminal angles are angles in the standard position with the same terminal side. Like this angle 120, this positive angle 120, we started from this initial side and we rotate this way. Okay, we stopped at this terminal side, so this angle is 120. If we start from the same initial side, but this time we rotate clockwise direction and we stopped at the same terminal side, we will have another negative angle, -240. 120 and the -240 are 2 coterminal angles. Why? Because both are in the standard position and both have the same terminal side. Guys, there are infinitely many coterminal angles. Don't think 120 and the -240 are the only 2 coterminal angles. There are infinitely many coterminal angles of the same original angle. So if you take the angle 120 and you need another coterminal angle, for example, if we need a positive coterminal angle of 120, positive coterminal angle of the same angle 120, how do we obtain another coterminal angle? Isn't the other coterminal angle only -240? No, there are infinitely many coterminal angles with the same angle 120. How do we obtain them? By adding any number of complete rounds. So I can add 1 complete round, 360, or 2 rounds or 3 rounds or 4 rounds, any number of rounds, because when you do a complete number of rounds, you stop at the same terminal side. Do you understand my idea, guys? So if you add 120 plus 360, you will get 480 degrees. This is a third or a second coterminal angle with 120. To obtain a negative coterminal angle of 120, instead of adding, guys, instead of adding a complete number of rounds, you can subtract any complete number of rounds. This time I'm going to subtract 2 rounds. 2 times 360. So guys, it's 120 minus 720. 120 minus 720. Let me double check. 120 minus 720 is going to be negative 600. Negative 600 degrees. Guys, the diagram only show one coterminal angle with 120. The diagram only shows the negative 240, but 480 is another coterminal angle. Negative 600 is another coterminal angle with the same original angle 120. So how many coterminal angle of one angle? There are infinitely many coterminal angles. Example 2. Find the measures of a positive angle and the negative angle that are coterminal with 65. Guys, to get a positive coterminal angle with 65, simply you add any number of complete rounds to 65. I'm going to add only one round. 65 plus 360 simplifies 425. 0 plus 5 is 5, 6 plus 6 is 12, 2 and carry 1 over, so it's correct, guys. So 425 is a positive coterminal angle with 65. We need another negative coterminal angle. Negative coterminal angle. This time, guys, I'm going to start with my original angle 65, and instead of adding any number of complete rounds, I'm going to subtract any number of complete rounds. I think it's enough to subtract 1 round. You will get a negative angle. You will get negative 295 degrees. So we get a positive and the negative coterminal angles of the same angle theta equals 65. Another example, guys, theta equals 410. This time the measure of the angle is quite large, so to get a positive coterminal angle, you can even subtract 1 round, because 410 minus 360 is still a positive number, or you can add any number of complete rounds, but this time, because the number is 410, I can subtract 1 round and get a positive coterminal angle. 410 minus 360, this is 50 degrees, 1 positive coterminal angle. I need another negative coterminal angle. Guys, 410, we already subtracted 1 round and we got a positive one, so we need to subtract more than 1 round. This time let me subtract 360. 2 rounds. So this is gonna equal 410 minus 720. 410 minus 720 is equal to negative 310. Negative 310 degrees. So we got a positive and the negative coterminal angle with the same angle theta. Remember, guys, there are infinitely many number of coterminal angles of the same angle. See you in the other part of this section. Bye.